Hi, so yeah, I'm going to be doing some more maths because my iPod was about to die, but now I've resuscitated it. Anyway, so last time I was talking about quadratics, but one thing I'm going to cover now is sketching quadratics.
So, sketching quadratics.
So when you're sketching quadratics, you want to find a couple things. One of which, easy to find, is the Y-intercept. If you really know linear graphs, then you know what the Y-intercept is, but yeah. Okay. The roots, or I suppose X-intercept, if you want to call it that.
Close.
The turning points, or you can also call these maximum or minimum points. I'm just going to call them
Maximum points.
Yeah, those are the 1, 2, 3 things that you're probably going to want to find when you're sketching a quadratic. So, for example, let's say you have y equals x squared plus 4x plus 7. Well, I already know to find the y-intercept, that's basically where on the x-axis x is equal to 0. So if we substitute 0 quickly into here, well, 0 to the power of 0 squared is nothing. 4 times nothing is still nothing. So therefore, y is just 7. So we know that it's 7. Now the roots, well, basically, we can just substitute 0 into y, and therefore we can just factorize this. But right now, I'm going to use the completing the square thing, I think it's called. But basically, we do x plus 2 squared.
And
It's plus 3. That's what y is equal to. Yeah, I forget why, but that's just it. And what this basically tells us is that the roots are at, now that I think of it, I don't think it has any roots. I'm just deciding that right now. It doesn't have any roots. But what I can tell you is that when you do complete the square, you're able to find the turning point from here. See, the turning point is always the minus of whatever this is inside the bracket and the whatever it is here. So the turning point here is -2, 3. So if you were to actually draw this graph, the y-intercept would be 7. So you label 7 here. The roots, well, you can use the discriminant to prove that it doesn't have any roots. And I mean, if you prove that it has roots, then yeah, you can go find the roots with either quadratic formula, factorizing, or completing the square. But otherwise, if you complete the square, you can also find the turning point, which just so happens to be -2, 3. So -2, 3 right there. Basically, when we sketch out the graph, something like that. And yeah, I think that's just how you sketch quadratics.